Example 21 on page 561. Simplify to form a plus bi. We're given I to the 23rd plus with I to the 48. Both I with different exponent. Now, we are asked to simplify this to the form a plus bi, which is a complex number. This complex number can equal to a real number if the coefficient b equal to 0. 0 times I is 0. A plus 0 is a. So, we're given this I to the 23rd power plus I to the 48th power. We don't know what I to the 23 or I to the 48. We don't know what it is, but we do know that the I and the I square. Now, because we're asked to write in this form that involves I, so every time you see I, leave I as is. Don't convert I to the square root of -1, because we're asked to write the answer with the I. But when you see I square of any I that are different from I, make sure you convert that to a real number or I. Okay? So like this case, we have I to the 23rd, I to 48. Both are not I, so make sure you simplify this. To simplify the two, I to the 23rd and I to the 48, we will write each to the form to the I we know, which is I squared. Okay? We're rewriting I to the 23rd in terms of I squared, and then we can use this number -1. And similar here, we will rewrite I to 48 in terms of I squared, so that we can use this value -1 for I squared. So I to 23, every time you see the exponent odd, make sure rewriting this exponent to even exponent, because with even you can factor the exponent. You can factor out 2, the exponent 2, so that we can use this formula I squared. Alright, with odd 23 exponent, I will split this to I 22nd times I. So as you see, I to the 22nd exponent times I is equal to I raised to the 23 exponent. And the goal is to get an even exponent so that I can factor this exponent 22 in terms of the exponent 2. For this, since this is even, the exponent 48 is even, so which is good. You don't have to split it. All you need to do is rewriting the I to the 48 exponent in terms of I squared. Okay, in terms of I squared. So the exponent is 2, but the original is 48. So think about 48 divided by 2 is equal to what? 48 divided by 2 is equal to 24. So this 24 would go outside the parentheses at the outer exponent. Okay. So I'm rewriting the I raised to the 48 exponent to I squared, everything raised to the 24th exponent. And you can test it. Take the exponent 2 times the exponent 24. You should get 48. Okay. Now, with I 22nd exponent, we will follow the same procedure like the I to the 48. We will rewriting the I to the 22nd to the one in terms of I squared. Okay. Now, because we're given 22, so think about 2 times what is equal to 22, or you don't see that, you can take 22, the original exponent, divide by the 2 here, you get 11. So the outer exponent is 11. And you can test it. 2 times 11 is 22, the original exponent. And then this i's would go here as time I, plus go here. Now for this, you can simplify this by, so the outer exponent to the same, still the same at 24. The inner I squared, you know, because you have this formula here, I squared equal to -1. So I'll replace -1 in place of I squared here. which is -1. And similarly, we have I squared inside. You can use this formula, I squared equals -1. So replace -1 for I squared. And this raised to the 11 exponent times I plus, now you have -1 inside the parenthesis. 1, when you raise to any exponent, is equal to itself. For negative, if it's raised to an even exponent, even, like 24 here, this negative will become positive. So think about this. Let's say k, this will equal to 1 if k, the exponent k, is even. Okay? And then similarly, you have, let's say, make it t, okay, will equal to -1 if t is odd. So when you raise to an odd exponent, -1 equal to -1. If you raise to an even exponent, when you simplify this, it will equal to 1. So we have the exponent 11 here. Sorry, I'm still continuing from here. So from here, -1 raised to an even exponent, for even exponents, which is right here, this will always simplify to 1. So I can simplify this. -1 raised to the 24 exponent will equal to 1. And how about this? For this, -1 raised to 11, and 11 is an odd exponent, which is here. Let's say if the exponent is an odd, when you simplify this, you would get -1. So -1 raised to 11 is equal to -1 times I plus 1. And simplify this, you would get -1 times I is -I plus 1. We are close. Now for complex number, usually we write the terms that has I at the end, just like this. Any number without I go first, and any number with the I you leave at the end. So I will switch these two terms because this one has no I, this one has I. So simplify by switching or rewriting. We have 1 subtracts I. Basically, I'm just switching these two terms. So 1 go here, -I go here. So the answer for example 21 is 1 minus I. And you see, we get the answer in this form. So the answer is a complex number.